Hello, Ben.
What are you doing, Dad?
I'm making a video on vectors for all the people. Are you going to say, good luck with vectors, people? You going to wish them all the best?
Good luck, doctors, people.
It's time for Maths with Mr. Thomas.
That's right. And what we're going to do is move on to lesson number 3 in the vectors chapter. We're still looking at vectors in 2D, but we're now moving on to look at vector components. Yeah! So what's this all about? Well, you know what a vector looks like already. You know a vector looks just like a straight line. There is an arrow to show the direction you're moving, and you're moving from a start point to an end point. What we can do though is if the vector is drawn on a grid, you can start to bring in numbers to represent that vector. Because these ones here I'm going to be doing today are in 2D, there is going to be 2 numbers to represent the vector. The first one will be the horizontal component. It is how far you are moving. If let's say that's your vector, if you're moving from this point to this point, well, it's how far horizontally you would have to move. So you would have to come along here. That would be the horizontal component, and then the other number would be your vertical component. That would be how far up or down you would have to move. The thing that you need to remember is if you have your x and your y axis, you know when you are plotting points, if you're coming along to the right, that is a positive number. If you're moving up the way, it's a positive number. If you're moving to the left, you start to go into negatives. You'd have -1, -2, -3, and so on. And it's the same if you move down the way. You would come down to -1, -2. We have to remember this when we are dealing with vectors and writing them in component form. If we are moving to the right, the number will be positive. And if we are moving up, the number will be positive. If we're moving left or down, though, it will be a negative component. Let's try some examples with this. So we've got this vector here. What's this vector known as? AB. It is known as AB. Thank you, Steph. So to go from A to B, let's think about what we would do. So if we are starting at A, you can see the vector is going in this direction. So this is our starting point and this is our end point. So if we're starting here and finishing here, this vector drawn in is really the shortcut to go from A to B. But if we're thinking about the horizontal and the vertical components, we need to think first of all how far we would have to move horizontally to get from A to B. Well, really what we would have to do is we would have to come along here, and then we stop directly below that endpoint of B. How many boxes did we move along? 4! Good, which means our horizontal component, because we moved to the right, it will be +4. And then after that, where would you go? Well, you'd have to go up. Good, and how many boxes are you moving up? 2. Good, which means then the vertical component, because we moved up the way, again think about your x and your y axis. If you move up, it's a positive number. Because we moved up 2, it is 2. These numbers here are referred to as the components of the vector. So you could say AB has the components 4, 2. Because to go from A to B, you had to go along 4 boxes and up 2. Let's try another one. This time CD. Once again, we're thinking about the horizontal and the vertical components. Which one would we start at, C or D? You'd start at C! Good, you would, because you can see the arrow is heading down in this direction. So we are starting at C and we're finishing at D. So once again, think if you move horizontally and vertically only, how would you go from C to D? Well, you would have to horizontally, always move horizontally first. You would move horizontally just along this one box, which means the horizontal component will just be 1. Once you've done that, you're going to have to move vertically. So how far down or up would you move vertically? Well, you would move down 3. You would move down 3. Good. So you move down 1, 2, 3. And because you're moving down the way, it's a negative. It is. So you would have -3. Again, right or up is a positive number, left or down is negative. Let's try another one from E to F. So this time we have EF. We've got a point E here, and we've got a point F here. Which one do we start at, E or F?
We start at E because the vector is going from E to F, which you can tell by the arrow.
Mark, you are perfectly right. Yes. So to go from E to F, well, again, think horizontally. How far would you move? Well, horizontally, we have to move back to the left. 1, 2, 3, 4, 5, 6 boxes. Which means then that horizontal component would be 6. Is that right?
No, it would be -6.
Why?
Because you move backwards, you move to the left.
Good, which means the horizontal component will be -6. Very well done. Wally, where do you go now?
Well, you go down 2, and because you're going down, it's a negative, so it'll be -2.
Well done, Wally. You're perfectly right. Let's try another one. This time here, we're going from H to G or G to H. Which way are we going? Help me out. Yeah, you guys have got this. Good. You're going from G to H. You can see the arrow is going up the way, so we had to start down at G and then go up to H. So, this time, horizontally, how far would we have to move to go from G to H?
0.
You're perfectly right. Yeah, you wouldn't move at all. You wouldn't be going along this way. That makes no sense, because then if you go up or down, you definitely don't get to H. The same if you start moving to the left and then move up or down, you definitely don't get to H. You'd have to move along 0. So the horizontal component will just be 0. You're not moving along. The vertical component then, vertically, up and down, well, you are moving up. 1, 2, 3, 4, 5. Once I caught a fish alive. Which means the vertical component will be 5. You've got this. Well done. Woo! Yeah. And as I said, these numbers are known as the components of the vector. So let's try a few more. Use brackets to write down the 2-dimensional components of the following vectors. This one here with a B. Once again, think which way are we going? Good, we're going from A to B. The arrow is going up that way, which means we start at A and we go to B. Once again, always think about your coordinate grid. If you are plotting points, you know this number would be 1, 2, 3, 4, 5. That is the positive direction. And then you'd be going up for, again, the positive direction. If you are plotting the point -1, 2, well, you know you're going back 1 and then up 2. So moving to the left is a negative. And if you're plotting the point -1, -5, well, you would go back 1 and then down 5. So if you move down the way, it is also a negative. Keep that in mind when you are doing these. So with AB, you are going from A to B. So think, first of all, horizontally, how far would you have to move? Well, you would have to move to the right. 1, 2, 3, 4 boxes. And then we're directly below B. So the horizontal component of AB is going to be 4. After that, where would you move? Caitlin? Yeah, you're perfectly right. You would have to move up 1, 2, 3 to get to B, which means the vertical component will be 3. So AB you can write as 4, 3. Woo! Let's try another one. With CD, where are you going?
You're going from C down to D because you can tell by the arrow.
Yes, you are perfectly right. You're starting at C and you're going down to D. The arrow is going in this direction. So horizontally, how far would you have to move?
Well, you'd have to move back the way, and you'd have to move back 1, 2, 3, 4.
Yes, Paul, you're perfectly right with this. You're moving back 4, which means...
That means you'd have, is that 4? Or is it -4? I'm not too sure.
Well, think about it. If you are moving to the right, it's a positive. If you're moving to the left, it's a negative. So here, to go from C to D, we had to move to the left.
Oh, so it was -4 then?
You're perfectly right, Paul. Well done. And from this point, we're directly above D. So to go from here, we're then going to have to move down 1, 2, 3, 4, 5. Once I got a fish alive. And that then would be -5. Yeah. Let's try EF. Again, the arrow is going up in this direction, which means we're going from E to F. And to go from E to F, the horizontal component, what would that be, Alan? Good. So horizontally, you would have to move back 1, 2, 3 boxes. So our horizontal component would be -3, because we had to move back the way to the left. After that, from that point, we're going to have to go to F, so we're just going directly up vertically 1 box, which means then the vertical component will just be 1. Woo! And final one, GH. Again, that's going from G to H. The arrow shows you it's going in this direction, so you started here and finished here. So if we're starting at G, horizontally, remember always move horizontally first, where would you have to go, Claire? Brilliant, you would have to move along 1, 2, 3, 4, 5, 6 boxes, which means then, Claire, 6. Well done, 6 would be that horizontal component. Steph, after that, we're moving down 1. Good, you are moving down 1, which means -1. Well done, because you're moving down 1, the vertical component will be -1. So all of these, this is representing the vectors using components. Let's try drawing some then. So, second example. Example 2, on squared paper, draw the vector A, which has the components 7, 4. So, what you want to do whenever you are drawing the vectors, what you want to do is you just want to find a place to start. So let's say we're just starting here. Make sure when you are starting it, you're starting where the lines on your squared paper cross. So just go to one of these places where they cross and then just put a wee dot, which is what I've done just there. So, I've got my wee red dot, that's where I'm starting. Because I've got the component 7, 4, always remember the horizontal component comes first, and because it's positive 7, we are moving to the right. We're moving in the positive direction 7 boxes. So we'd move along 1, 2, 3, 4, 5, 6, 7. We have moved along 7 boxes. 1, 2, 3, 4, 5, 6, 7. From there, because our vertical component is 4, we want to go up directly 1, 2, 3, 4 boxes, which means that then will be the end point. So we can mark that on. So we've got our start and we've got our end. Remember, we came along 7 and then we went up 4. What we then want to do is we just want to draw that vector in. So we would use a straight line, use a ruler for this. So let me get some to draw it with. And from the start to the end, we would draw in our vector. Which way would the arrow be facing? Is the arrow going to be facing up this way, or is the arrow going to be facing down? Brilliant, the arrow would be facing up the way because we started down here, and to go from this point up to here, we would have to go in that direction. So that there will be our vector A. And make sure you write in what the vector is beside it. Lowercase letter, and then underline it. Let's try another one. This time, draw vector B, which has components 2, -5. Once again, get a starting point. This is a starting point I am using, and we want to first of all go along horizontally 2 boxes. So we go along 1, 2, woo! We've done that. Now the vertical component is -5. Stan, what does that mean? Brilliant. We want to go down 5. So go down 1, 2, 3, 4, 5, and that will give us the end point. So we've got the start point and we've now got the end point. So start and the end. Again, we went along 2 to the right and then we went down 5. Once we've done that, just draw that line in. So draw the line from the start to the end, just using a ruler. And then think, which direction would the arrow go? Yeah, you're right, that was the very start, that's the very end, so we had to come down in this direction. So you would have the arrow going like that. And once again, because that's vector B, just put a B beside it. B for big vector. Example 4. On squared paper, draw the vector C, which has the components -4, 2. So, because it is -4, Leah, what would you have to do? Good, you would get your start point and then you would... Good, you're moving to the left. 1, 2, 3, 4. Brilliant. So go to the left. 1, 2, 3, 4 boxes. After that, Moksha. Brilliant, good, because it's +2. It means we would go up vertically 1, 2 boxes. So we'd have our start point and our end point. So we can highlight that just on the bit of paper, looking something like that. There's the start and there's the end. From there, we would draw in our vector from the start to the end using our ruler. And then think about the arrow. Because we started down here and we finished up here, we had to go in that direction. And put the C beside it. That there is vector C. That's what it will look like. C for clever vector. Yeah. Next one, on squared paper, draw vector PQ, which has the components -8, -3. Again, just get a random starting point. And we've got the horizontal component -8. So with -8, we are going back 1, 2, 3, 4, 5, 6, 7, 8 boxes. Woo! And then we are going, good, we're going to have to go down 3. So we're going down 1, 2, 3. So we will find that end point. So we can mark them on something like that. Once again, once we've got the start and the end, again, we have to go back 8 to the left because it's a negative, and then down 3 because it's a negative. Once we've done that, we can draw the vector on. Whee! Straight line from the start to the end. This time the arrow would be going, good, the arrow's going down the way because that was the start and that was the end, so our vector would look something like that. Because this is vector PQ, what we would do is the starting point is going to be P, so we'll just put a big P beside that. And because that goes down to Q, we'd put a Q beside that point. So we've got the vector PQ. Ta-da! Example 6. On squared paper, draw the vector ST, which has the components 9, 0. So with this one, once again, get a starting point. Ta-da! We have a starting point. Our horizontal component is 9, which means we're going along 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. And once we've done that, how far up or down do we go? You're right, we go up or down 0 because the vertical component is 0, which means we're not going up. It means we are not going down. We are moving 0. So we just stay there, which means that there will be our end point. So we have our start point and we have our end point. So it looks something like that. Once we've done that, we want to draw our line between these 2 points. So that there will be our vector. And which direction will the arrow go? Good, it's going to go off to the right because that was the start, that was the end. If we start there and finish there, we have to go in that direction. Because that is the vector ST, what it means is we would put a giant S, a capital S at the start. Our arrow goes in this direction and we finished at T, so we'll put a capital T just over here. Hopefully you're managing these vectors, you're managing to draw them using the components, but once they are in component form, it makes them so much easier to add them or subtract them or multiply them by a scalar. So let's try some examples with that. Let's say, for example 7, we've got these 2 vectors A and B. Let's say A has the components -2, 5, and B has the components 4, -6. Let's say we want to add these 2 vectors, A plus B. Well, you know from the last lesson you would really have to draw that first vector, and then where that vector ends, you would then draw the other vector. And really what you would then have to do is you would have to draw the answer going from the start to the end. But we don't need to bother doing all that now because they're in component form. And once they're in component form, if you're adding the vectors, all you have to do is just add them together. So you've got the -2, 5, add on the 4, 6. And to add them, what do you think the answer will be? Yes, it is as easy as that. All you do is you would add these horizontal components, which is -2 and 4. So -2 add 4 is? Good. Whoops, it's a big green box. So -2 add 4 is? Good, that is 2. And then 5 add -6. Well, remember when you add a negative, you're taking away. So 5 take away 6 would give you -1, which means if you drew it out, vector A plus B would have the components 2 and -1. If you're subtracting the vectors, if you do A take away B, well, vector A is -2, 5. You're taking away the 4, -6. If you do that, well, again, all you do is -2 take away 4. It gives you -6. And 5 take away -6. What happens when you take away a negative? You're that! You do, so it's really 5 add 6, which is 11. Woo! If you've got 3a, well remember this is the vector a, and what we're doing when we've got a 3 beside it is we're multiplying it by 3. So really we've got 3 times by that vector a. We've got 3 times the negative 2, 5. And to multiply the vectors by a scalar, all you do is you multiply the components each by 3. So you do 3 times the negative 2, which is negative 6, and you do the 3 times the 5, which is 15. Which means if you drew out 3a, you would end up with the components negative 6, 15. Negative a half b. Well, you're taking vector b and you're multiplying it by the negative a half. So you could write it out just like that. Negative a half times by this vector b, the 4 negative 6. Once again, similarly, when you had the 3, you were doing the 3 times by each of these numbers. Here, you're multiplying each of the numbers by negative a half. Really, to multiply by negative a half, you're just halving the numbers and then multiplying through by the negative. And when you multiply through by the negative, you really just change the sign. So a half of 4 is 2, and when you multiply through by the negative, you will end up with negative 2. For the negative 6, half of negative 6 is negative 3. If you multiply through by the negative and the negative will make a positive. So you get positive 3. So negative a half b would have the components negative 2, 3. And doing that, working with the components, rather than having to draw them all out, is so much quicker. Other things you can do with the vector components is you can solve equations. So let's say we've got vector x, add on this vector 8, negative 3, equals 12, 4. How would you go about getting x?
Well, what you'd have to do is you'd have to take away that vector, the 8, negative 3.
You're perfectly right. So you would have the 12, 4, and you'd be taking away this vector. Really, to get rid of the add that vector, you would take it away. But on the other side, you would also have to take it away. That would leave you just with vector x on the left, and on the right hand side you have the 12, 4, take away the 8, negative 3. And once again, to do that, well, you're really doing the 12 take away 8, which is 4, and 4 take away negative 3. When you take away a negative, you add! Good, so it's 4 add 3, which gives you 7. So vector x will have the components 4, 7. Example 9, solve this vector equation. If you've got 5 times by vector x, well, that would equal negative 35. It is this vector with these components. But we just want vector x, we don't want 5x. So how do we get rid of this multiply by 5? Just do the opposite. And what is the opposite? Divide by 5. Good, you're dividing by 5. So if you divide that by 5, you would end up just with vector x. But on this side, you're dividing this by 5 as well. And when you divide something by 5, really what you're doing is you're taking a fifth of it. So you'd end up with a fifth of that vector, negative 35. So to work that out, just take a fifth of each of these numbers. Just divide these numbers by 5. So negative 30 divided by 5 gives you, good, it gives you negative 6. And 5 divided by 5, yeah, you're really good at this. High five. That will be your answer. And final example, example 10, solve the following vector equation. 2x take away 7, negative 6 would equal negative 3, 8. So 2 times vector x, take away this vector equals this vector. How do we go about solving that? Good, we'd have to get rid of this, take away this vector. And how do we cancel out take away this vector? Good, you would add that vector, that would get rid of it. But on this side, you would also have to add that vector, which means then 2 times vector x would equal the negative 3, 8 plus the 7, negative 6. Woo! From there, well, you can actually work that out. If you do negative 3 add 7, go on RP, what would you get? Good, you would end up with 4. And if you do 8 add negative 6, yeah, that is 2. Well done, RP. With the 2x equals the 4, 2. Well, that's 2 times vector x. Again, you just want to get vector x on its own. So how do you get rid of that? Times by 2. Good, you would divide both sides by 2. So vector x would be, and if you're dividing it by 2, you're halving it. So it's half of the 4, 2. And to work that out, just half each of these numbers. So if you half the 4, you end up with 2. Good. And if you half the 2, you get 1. Brilliant. Which means vector x just on its own will have these components 2, 1. And once again, that's the horizontal component, and that is the vertical component. Give these questions a shot in the TJ National 5 book. You're on page 145, exercise 15.2, or use any other page or textbook you like. Give some of the vector component questions a shot, though. They come up all the time in the exam, so it is something you need to know inside out. Good luck. Any problems, give me a shout. Hello, I'm stuck. I'm coming. I'll help you. Bye.